While we can compare two means, we can also compare two variances, two standard deviations, or even two proportions. And so what we need to learn how to do is read a problem or look at a situation and recognize which is the appropriate test. And so in this example, let's just read it and see if we can recognize what we need to do. It says to test reliability, we subject samples of 30 electric motors and printers from 2 suppliers to severe testing. Of the motors from supplier 1, 22 passed the test. Of those from 2, only 16 passed the test. First thing I'm noticing here is that we're given counts. We're not given statistics. We're given just counts, how many. Really, the only thing you can do with counts is percentages or proportions. But let's take a look at the question anyway. It says a significance level, or alpha, of 0.05. Is there evidence there is a difference? Okay, that's going to be two-tailed. In the proportion, etc., etc. Okay. Well, there was my key phrase, but I recognized it before because we were given counts. Is there a difference in the proportion? And then we'll take a look at B after we run through the test. So I have 2 groups, and I'm talking about proportions, and I want to know if there's a difference. They're 2 completely unrelated groups, so these are independent samples. So what we're trying to do is test an H naught and HA, that the proportion in group 1 is different from the proportion in group 2. So a two-tailed test. Now I have a choice here of how I do this, right? I can use the p-value or the rejection region method. So what I want to do is actually look at both. So what we'll do is over here we'll do the rejection region method, and over here we'll do the p-value method. Now, of course, when you are doing a problem or you're doing your own research, you choose one of these. You don't actually have to do both methods. You only need one. They're just 2 different ways of doing the same problem. Now, as long as you have a large enough sample size, the way that you'll do this is something called a 2-prop z-test. And a large enough sample size will always be the case in our problems. And so we're going to do, again, as before, a lot of the calculations on the calculator simply because the formulas at this stage get quite tedious. And so what I'm looking for on the calculator is a 2-proportion z-test. And what it asks for is the number of successes. So x1 is the number of successes in the first group, that's 22. And x2 is the number in the second group, and that's 16. Before I need that, I need to also put in the sample size. So n1 is 30, x2, as I mentioned, 16. And notice it said 30 for both suppliers, so n2 is also 30. And this is a two-tailed test. Now all I need to do is calculate. So we're given a lot of values here. You might find this helpful if you do anything in by hand at all. We have the p-value, then we have p1 hat. That's the percentage of successes in the first sample. We have p2 hat. That's the percentage of successes in the second sample, or proportion. You can convert it to a percent. And then the p hat by itself, that's actually the pooled estimate. Your book calls that p bar. And you can use that in the formula for the test statistic, although you don't really need that because we have our test statistic here, which is z equals 1.60, let's say 7. All right, so what I need in the rejection region method now is to compare this to a critical value, right? So I need my rejection region. And so if I have my rejection region, it's going to be from the z distribution, in other words, the standard normal, simply because the proportions follow, the difference of proportions follow a standard normal distribution as long as you have big enough sample sizes. So here's my standard normal distribution. Looks a lot like our t. They're actually slightly different. It's just hard to draw much of the difference. And this is a two-tailed test, so half of alpha is going to go out here, and half of alpha is going to go out here. So this is going to be a z, and this is going to be a negative z. And so I only really need to find one of these. Alpha was 0.05, so this will be 0.025 over here, and this will be 0.025 over here. Okay, so for z, what I can do is use inverse normal. And so what I want to do is an inverse norm of 0.025, and that'll give me the negative z, and then I'll know what both of my z's are. So if I do an inverse norm, go to second distribution, inverse norm, and then I put in 0.025, I get a negative 1.96. And so that's my negative z, negative 1.96, and this is 1.96. Already looking at z, I can tell we're going to end up failing to reject H naught, right? Because our z right here is not in the rejection region. Instead, it's maybe about right here. It's a little off from the rejection region. And so I would say that I failed to reject H naught. We'll interpret that in a moment. Now, correspondingly, if I was to do this with the p-value method, I should have the same conclusion. And so when I look on my calculator at what the p-value was, the p-value was actually a little high. It was 0.1079, so let's say 8. So about 10.8%. We were doing an alpha of 0.05. This is certainly bigger than that. This would even be bigger than alpha 10%. And so I come to the same conclusion. In both cases, I failed to reject H naught. Now the question is, what have I really shown? To answer A, is there evidence the difference in proportion in the proportion of motors that perform well from the two suppliers? I can't say there's a difference. I would have to say that we have no evidence of a difference. And that automatically brings me to question B. Can we claim to have shown that they produce equally reliable motors? In other words, can we say that we proved H naught? And the answer is no, you can't. We can never say that H naught is true because we assumed it was true when we did all our calculations. All we can say is we didn't prove it wrong. Now, you put this in a business setting, which company do I buy from? And you could think of it this way, well, we didn't prove they're different, right? So it probably doesn't matter which one you buy from, but we're not saying for sure they're equal. It could be that something in our sampling procedure or something did this, but also it could be random chance if we see a difference. This is saying with the p-value, there's a 10.8% chance of randomly seeing a sample like this if they're the same. So that is what you should use to make your decision with whether or not you were to buy a motor from one company or the other. But remember, we can't totally prove H naught. You can never directly prove H naught. And so as we go through these types of problems, be careful with your interpretation. That's why I tend to focus on HA the most. So again, once we use the calculator, the calculations are very quick and easy. It will be the same if you do it by hand. I highly advise avoiding that. And then the inverse normal is used instead of the t-table because proportions will follow the sampling proportion for p hat. The sampling distribution for p hat will be approximately normal.